Hello everybody, it's Mac here and we are going to deal with fractional exponents. Fractional exponents, what the heck is that? Well, if we have an exponent, well first of all, let me just give you the rule right here. The rule is this. If I have x to the a over b, that's going to look like the square root sign, but it's going to be x with the numerator here and the denominator there. Okay, so the best way to do it is just to do a few of them. I'm going to start with number 1, 16 to the 1/2. What in the world would that be? Well, what I'm going to do is I'm going to make a square root sign, and this is I'm sorry that it's written kind of left to right instead of top and bottom. I don't love that. But what I'm going to do is that's the denominator, so that becomes the square root, and that's a 16. Now, I didn't write the 2. Why didn't I write a 2? Because it's assumed to be a 2. If you don't write anything in there, it's a 2. So that just means square root of 16, which is going to be 4. Now, let's compare that over here to 9. Now, this one, they want you to write it as a fraction. So I'm going to do this. X to the, now, the exponent that is given is a numerator, and the type of root it is the denominator. So that's just going to be x to the 2/3. That's all that means, okay? Now, let me go down the left side, then I'll go down the right side so you can kind of get an idea what this means. This one means I'm going to do the radical. Now, the denominator is a 3, so that's going to be a cubed root of 27. 27 to the first, but I don't really need to write to the first, but that's what the 1 means. Now, do you guys know what the cubed root of 27 is? You should know it by heart. But that's going to be 3 times 9, which is 3 times 3. Well, whatever. It's 3 times 3 times 3. Square cubed root of 27 is 3. That's the one I want you to commit to memory. Okay, this one right now is going to be 49, and it's a square root because of the 2. I don't need to write it because it's assumed, and that's just going to be 7. How about this one? This one's a little bit nutty. Okay, so this one I'm going to write the square root sign, but because the denominator is a 3, that has to be a 3, and this is 125 squared. I don't think I gave myself much room to do this. Now, the best way to do this one is to do it like this. I'm going to go 125 times 125. I just wrote it twice, correct? And so this is going to be 5 times 25, and this is going to be 5 times 25. And then that's going to be 5 times 5. And then that's going to be 5 times 5. Okay, so now 1, 2, 3, I pull out a 5. And 1, 2, 3, I pull out another 5. My answer is 25. Okay, but learning that 125 to the 2/3 equals that is what I was trying to get you guys to. Okay, here we go. So 64 to the 1/6. Well, that would just be a 64 here, and it would be a 6th root. Okay, so now to do this, I'd have to break down the 64. I'll do this off here on the side. 64 is 8 times 8. Would you agree? And then 8 is 2 times 2 times 2. And this 8 is 2 times 2 times 2. How many 2's do I have? 1, 2, 3, 4, 5, 6. Hey, I needed 6. The answer is 2. Okay, because I was able to find a 6 of a kind and pull it out. Ugh, this one looks ugly. 81 to the 3/4. 81, boom. Now, the 4, because it's the denominator, it goes here. The 3, the numerator, it goes here. Now, before I go any further, let's just do this. 81 is 9 times 9, right? But I've got 3 of these 81s. So 81 and 81, there's another 9 and a 9, and there's another 9 and a 9. Okay, and I need 4. 1, 2, 3, 4. Hey, I can pull a 9 out. Cool. Now, I only have 2 9s left, but watch this. 3, 3, 3, 3. 1, 2, 3, 4. I can also pull out a 3. So what's my answer? There's nothing left inside. So my answer is a normal everyday 27. Okay, I know that's a little bit weird, but go with me on this. Okay, the 243, a 5th root of a 243, that just looks scary. Okay, but that's okay, we can do that. Let us go to 43, and I'm going to do a root, and it needs to be a 5th root. And that's to the 1 power, so we'll just leave it there. Now, what will go in the 243? Well, the first thing I do is I see I'm not sure right now. That looks like something that I should know. But I'm looking 2 plus 4 is 6. 6 plus 3 is 9. So I know 3 will go into it. Will something bigger and better go into it? I don't know. So I'm going to break that down. 3 times 81. 81 will become, I should really do this up here, shouldn't I? 243 is going to be 3 times 81. Let me cross this stuff out right here. I'm doing it over here. That's going to become a 9 times 9. That's going to become a 3 times 3. And that's going to become a 3 times 3. And I need 5 of them. 1, 2, 3, 4, 5. Hey, 5 of a kind. My answer is just everyday 3. Okay, and number 8, 32 to the 5 over 5. Well, isn't that 32 to the first power? And wouldn't that just be 32? The answer is, yeah, it would. Okay, so now let's go over here. Now let's find, these are very different ways of doing it. It's just showing that you understand how to express them. So this would be m. The numerator is that. The denominator is that. Remember, whatever type of root it is, that is going to be your denominator, okay? So now this one is going to be x. The exponent of x is the numerator. Now, if they don't write anything, what is it? It's a 2, okay? So that's always assumed to be a 2, all right? They only write a number if it's not a 2. All right, so this one is going to be a to the 4 over 3. Number 13 is going to be p to the 2, do the root as a denominator. 14 is going to be q to the 5 over 6. The root is the denominator. This one's going to be x. Now, if you're going to have a denominator, you need a numerator. There is no exponent, so we write 1 kind of as a placeholder, right? And it would look like that. And number 16, what am I doing? Would be y to the 7 over 3. Again, the root is the denominator. Okay, so there's your introduction to fractional exponents. Obviously, some required some work. Some didn't require work, okay? It just was a bit of a thought process. Well, there's one. If you feel like you understand it, that's awesome. But I do have more. So I'll see you on the next one.